Hello, algebra students. In this video, we're going to be talking about transformations on the absolute value function. So in a previous video, we learned what the absolute value function looked like and why it looked like what it does. Right, it's this phi, it's two lines, the slope of up 1 over 1, up 1 over 1. But we know functions aren't always as simple as this. So what I can do in my next one in the orange is see what happens if I add a number to the outside. So if I add a number to the outside, look what happened. It's kept the same shape, but shifted up 3 units. So all the y values, 1 was added to it. Conversely, if I subtracted, it would shift down 3 units. So that's actually always what's going to happen when you add or subtract to the outside of an absolute value function. Okay, so let's see if I transform. What if I added 3 on the inside? So even though I added 3 to the inside, to produce those same y values, it's going to shift to the left. So notice how now all the x values, so when I add to the inside, my x values are affected, and it moves to the left that many units. Let's see, if I made it plus 4, it would move to the right 4. Plus 5, plus 6. That's how it's going to move. Plus a half. If I subtract, it's going to move to the right that many units, however much I do. And you could even do both at the same time. So it moved to the right 6, even though it's minus. That's what happens. And up 2. So you can actually take this hk, and I can even add a slider and give it certain values. So if I made h, this number here, negative, let's say 4, it's going to move to the right 4 because it's minus 4. Let's say I subtract 5 and down 5. Whatever these two values are, h will be the x value of the vertex, and k will be the y value of the vertex. So you can actually tell what the vertex is based on these two numbers. But we know you're not always just adding and subtracting to functions. Sometimes you can do the operation of multiplication or division. If I multiply on the outside, you can notice this orange graph is skinnier than the green graph. This was a vertical stretch. Because what happened is I took all the y values of the function. So let's say I called this g. I should call this something else. If I took all the original function of f, and if I multiply on the outside by 3, it's going to take all the y values, all the f of x values, and triple them. So that's why it's so skinny. If I were to multiply by a third, instead of multiplying by 3, it's going to take all the y values and cut them into 3 pieces. So whereas before I had the point 3, 3, it's going to take the y value, divide it by 3, and I'm going to have the point 3, 1. It's not letting me highlight. Here, I can type that in. 3, 1. And there it is. Now you're probably thinking, what happens if I multiply on the inside? Well, it's kind of strange. So this is actually a horizontal compression. So all the x, it's not quite the same as if I did this. Oh wait, it is the same. Haha, I'm just kidding. But what's happening is I'm taking all the x values and actually multiplying by a fifth. So whereas before I had the point 5, 5, now on the new one, see how that's on the old one, that's on the original. I'm claiming I'm taking all the x values to produce the same y values. I'm multiplying the x values by a fifth. So that means I would have the point 1, 5. And so it is true. If you were to multiply by a number less than 1 inside the absolute value, that's going to be a horizontal stretch. So when you work with the inside, it's kind of, I call it evil and opposite. Opposite things happen. So we saw vertical shifts up and down when you add to the outside, like a -2 or whatever. We saw horizontal shifts when you add to the inside. We saw vertical stretches when you multiply to the outside. We saw vertical compressions when you multiply by a number less than 1, horizontal stretches, and horizontal compressions. Thanks for watching this video.